Good morning, students. Last class, some of the power, the remaining we'll see now. Okay, now keep one. First one, mean horizontal candle power. Mean horizontal candle power, MHCP. It is defined as the mean of candle power in all directions in the horizontal plane containing the source of light. Containing the source of light is called MHCP, mean horizontal candle power. Okay, next one, glare. If the eye is exposed to every bright source of light, this this automatically contains in order to reduce amount of light admitted and permanent damage to inertia. This reduces the sensitivity, so in the field of vision can be only in terms of unseen. Okay, next one, beam factor. The ratio of lumens in the beam of a projector to the lumens gives out by lamp is called the beam factor. It's called the beam factor. Next one, reflection factor. Reflection factor. The ratio of reflected light into incident light. The ratio of reflected light into incident light is called reflection factor. Okay, still now these are all the basic definitions of an illuminations. Okay, next one, very important question, laws of illuminations. Laws of illumination. Okay, there are two laws of illuminations. There are two laws of illuminations. In that, first one is that inverse square law, and second one is that Lambert's cosine law. Inverse square law and Lambert's cosine law, very important. These two are derivative part. Okay, now we'll see one by one. First one, keep reading. Inverse square law. First we need to write that regarding that statement. It states that illumination of a surface is inversely proportional to square of the distance between the surface to the source of light. Just name only indicate. Illumination of a surface is inversely proportional to the square of the distance between surfaces to the source of light. That is the statement of an inverse square law. Okay. Next we will see derivation. Here, if the sphere is replaced by another sphere having large radius, the total amount of light is spread over a longer area proportional to the square of the radius. Just we have to make it a figure. That is a two areas A1 and A2 and corresponding to a distance or origin point S. That A1 is distance is A1 radius is R and A2 radius is 2R. Between that distance of A1 and A2 is that omega. Okay, let us consider surface area A1 and A2 at a distance r to r respectively. So based on the diagram we need to write the data. So regarding that, a distance of S2 A1 area and R is distance of an S2 A1 and 2R is S2 A2. Okay, from the point of a source of a luminous intensity I, let a solid angle subtend omega steradians. The surface gives that I lumens for the sun surface enclosed by omega. At that time, the omega angle, solid angle, omega is equal. Already we know the definition of omega. Omega is equal to area by distance square. That is an A1 by r square. And finally, a total flux on surface A1 is equal pi 1 equal to IA1 by r square. Illumination on the equal to pi by a1. Finally we need to submit all the data. E is equal to elimination, e1 is equal to I a1 by r square into a1. A1 get cancelled, the remaining word is that e1 is equal to I by r square remains for meter square. And similarly for this one, surface area 2, first we need to write that the flux value pi 2 is equal to iw. Elimination on the surface area is covered by a2. At that time e2 is equal to pi by a2. Already we know the value of an pi, just we have to place it that pi value. Then therefore elimination at surface second surface, e2 is equal to I a2 by 2 r square by o a square. A square get cancelled, remaining e2 is equal to I by 2 r square. So from equations 1 and 2 we will get that result of this, the elimination. C1 is proportional to e2, that is equal to 1 by r square is to 1 by 2 r square. So 1 by r is regarding to area is subtended by that the surface a1, and a2 is suspended by area e2. Then finally the result is that therefore e1 is to e2 is equal to 1 by r square is to 1 by 2 r square. Illumination at a surface is inversely proportional to square of its distance from the source. Our aim or intention is that inverse law. Now the corresponding distance is that r square is inversely proportional to illuminations. Okay. Likewise, we need to express for the star how number of distance we can consider. That all the distances is denoted as r. First distance r, second distance 2r, third distance third distance is the 3r, fourth distance is 4. Likewise, you have to express everything. Okay, each and everything should be expressed. Then the finally we will get the result is that elimination is inversely proportional to square of the distances. Okay, the next second live will see next class. Okay, thank you.